Welcome to this presentation of the InnoReach Spectrum Distributed Antenna System. My name is Tom Hebert. I'm a principal engineer, and today we're going to be talking about the latest in indoor DAS products. The Spectrum system allows you to extend wireless service into buildings or multiple buildings or campus applications. It's a very flexible and very scalable product. You can do multiple bands and you can do multiple operators all within one system. The Spectrum Distributed Antenna System has three major components. It has a host unit, an expansion group, and a remote antenna units. The host unit is the interface to the base stations or to the BDA, the bidirectional amplifiers, and that's where the source of the RF originates. From there, it goes over fiber to the expansion units. These take the digitized RF, converts it into a cable TV format. Cable TV lines, in turn, run out to the remote antenna units, which live at the location that you're trying to provide coverage. The remote antenna units are connected to an antenna that provides coverage at that location. So the InnoReach Spectrum Distributed Antenna System is very flexible and scalable. Let me give you a couple of points. You can do up to 8 bands within the system, and so any of the North American bands that are out there, you can do. So really, you are future-proofed against what you want to do. You can start out with a smaller number of bands and then grow it as your spectrum and your band requirements increase. Also, it handles 2G, 3G, 4G, really is a broadband transport, and so really it doesn't matter what the protocol is. The product supports it because of the broadband transport. The fiber connectivity. It doesn't matter whether you're running, short fiber or long fiber. It's digital fiber. The performance is the same at the minimum or the maximum distances. So the host unit of the Spectrum product would typically be located with your RF sources, your base stations, and your BDAs. And so these could be aggregated into a single location where you can really pull all those resources together in a very efficient fashion. And then using the long reach of the fiber optics going out to 10, 12 miles, you would run that out to your remote units or your expansion modules that would receive the digital signals and would provide the coverage within the 200 meters of the reach of the cable TV system. And from there, these cable TV lines run out to the various remote locations, but these remote units can live in just telco closets, or just other mechanical type rooms where you put electrical equipment. The cable TV lines run out through the walls and into the ceilings. They run out to the remote antenna units, and so these units are the ones that actually get installed up in the ceilings and or in various, on walls to be able to drive an antenna that gives you the wireless coverage at the given location. This is the InnoReach Spectrum host unit. It is a 3U rack-mountable unit. It can either be mounted into a 19 or a 23-inch rack. In this case here, I've got it with the 23-inch rack mounting configuration. There's a number of modules that make up this unit. You have the SURF module, which stands for Serial RF. So this is what takes the digitized RF and gets it out onto the fiber transport. This unit has up to 8 optical connections on it, so you could run up to 8 remote units that in turn can run 8 remote antenna units. And so there's a lot of scalability that's allowed. You can start with 1 unit and work your way up to multiple units, or you can add in additional spectrum by adding in fibers going to 1 remote unit. Additionally, on this board are the network connections. You have a network RJ45. This is typically how you would access the system remotely. You also have a Craft RJ45, which is used for local access by the technician that happens to be local with the site. You also have LED indicators on here that show you the status of this module. So you have power and some other status lights that really give you a local representation of the health of the module. Working down, we have the system board. The system board is really the frequency reference for the system, and you can either have an internal reference or an external, and it does support either 10 megahertz or 30.72, the CPRI data rates. It also has the dry contact supports, such that if there is an alarm on the system, you could drive a dry contact closure, indicating for the host or the remote whether there was a minor or major alarm within the system. The next module is the DC power supply. This allows you to take in a 24 or 48 volt DC input voltage and be able to run the host unit. And so this is good because a lot of times you have DC that's available at certain locations. It allows you to run on that backed up power. Over on the left-hand side here, we have a fan module. Fan module is used to draw air across the components to keep the unit cool. Over on the right-hand side are all the radio cards. These are what we call DART boards. It stands for Digital to Analog Radio Transceiver. And so you can have up to 8 DART boards within the host. And so those represent 8 different bands. You can have all the different bands that are available in North America, or you can have multiple bands of the same frequency. So if you wanted PCS, multiple times with multiple sectors for capacity reasons, you can install those boards. Or if you just want to get all your bands, you can have all the various North American bands that are available. And so these are, once again, hot swappable. So it's easy to add a band without affecting the other bands already in the system, or to do a maintenance action on the unit. Each DART card has 2 connections into it. These are QMA connectors. It has a forward input and a reverse output to provide the coverage within the system. These would hook up to your RF sources. Additionally, you have a power LED that just shows the card has power, and that should green up immediately once the card is put into service. And then you have a status LED that once the system or once the board is put into service and there's RF that's being carried on the system, that the software will turn that light green to let you know that you have service on that system. You can see that it's recognizing it now, and it's turning it red as it tunes the card up, and then eventually will turn it green. These RF darts, in turn, are connected to the IF darts out at the expansion group. And so you have a similar card out here. This is a DART board as well, but this is an IF dart. And so it will take those RF signals that were transported over the fiber and convert them into the IF frequencies that get used on the cable TV 75 ohm system. And so every band would have a set of IF darts as well that has 2 outputs, a forward and a reverse, that go to the IF expansion unit that come out onto the cable TV system to run out to the remote access units. I'm going to highlight some of the OEM aspects of the system. There are LEDs on all the units that make local debugging of the product very simple. In this case, we have a cable TV pair that's running out to a remote access unit. And so there's 2 ports, the reverse and the forward. And the 2 ports are showing that they're green, that it's a healthy status. Now, if someone were to detach the cable from that remote access unit, and we'll have that done now, you can see that I get a red indication that there's a problem now with that node, or with that access unit. And not only do you get a local representation, also in the element management system, you'll get an alarm as well. And so once they go out there and reconnect that cable, the system will automatically detect the fact that it's been reconnected, and then it will clear the alarm and the LED status, telling you that you have service going back out to that port. And so you can see the lights flickered there for a moment. It takes it a minute for it to recognize it, and then the LEDs will go green, and then the element management system would report a cleared alarm as well that would get reported out through the network. I'm going to highlight an important feature of the SURF module. The SURF module is the optical transport for the InterReach Spectrum distributed antenna system. In the SURF module, you have up to 8 ports for your optical transceivers. We use an SFP transceiver, which is an industry standard, and comes in a lot of different formats. But you can actually start with a small number of remote locations that you're trying to cover, and then as your coverage requirements increase, it's easy to just install one of these SFP transceivers into an unused cage to be able to provide additional coverage, all running off of the same host unit. These SFP transceivers come in IR and SR, IR and LR ranges, intermediate and long range, and they come in multiple wavelengths. Some of the benefits of that is that if you don't have a real ideal fiber plant, the long-range optical budget allows you to get through that less than ideal fiber. Additionally, with the WDM and CWDM wavelengths, you can actually work on existing fiber plants that don't require you to run your own fiber in order to get coverage within the system. Another important feature of the product is the ability to carry large bandwidth on a fiber pair. Each fiber pair can carry up to 70 megahertz of bandwidth, and so you can have up to 8 sets of fibers coming into a host unit, and so 8 times 70 is 560 megahertz of spectrum. So lots of capabilities built into the product. You know, lots of capacity can be carried on a single fiber pair. The IR optics have a link budget of 13 dB and can work out to 6 or 7 miles. You can go to the LR optics, which have a 26 dB link budget, and those can work out to 12 and 13 miles. Also, by having this long reach on your fiber plants, allows you to hotel your base stations and to really aggregate those resources within a single location and to achieve the benefit of that. The InterReach Spectrum product has a lot of scalability and flexibility to it. One important aspect of that is the ability to cascade units. We start off with our host unit, which is where the RF sources come into the system, and we run those fibers off to an expansion group. And so we can provide coverage at that location with up to 8 remote antenna or remote access units. And so you could expand the system by running fibers additionally from the host unit to the next expansion group, and that would require a lot of fiber to go all the way back to the host. But in the case of the Spectrum product, you can actually cascade. And so we can run the fiber into the first expansion group, and so instead of having to go all the way back to the host unit for the next expansion group, we cascade a set of fibers off to the next unit. And so it really is a much more efficient use of your fiber. It allows you to bring out some coverage, and if you want to extend it, you don't have to go all the way back and incur all that time and cost of running fiber all the way back. You can just cascade it from that endpoint to bring on additional coverage. And so you can do that up to 8 times. So you can have actually a cascade to 8 expansion groups to really expand the capacity of the system. Okay, these are the expansion group, and it consists of a DART remote unit and an IF expansion unit. These devices would live close to the wireless service area, and they're connected back to the host via the fiber. Within the DART remote unit, you have a fan that is hot swappable, easy to replace if you were to have some maintenance action. You have the SURF module, which has the optical transport that's talking back to the host unit. Additionally, there are network and craft ports for network connectivity to within the system. And then you have the LED indicators, which give you the alarm status of the device and things that are downstream of it. Next module is the system board. The system board is the clock reference for the DART remote unit, and you can either run it off an internal or external reference. It also has dry contact support that allows you to drive the inputs into the unit for alarming. And so if you're connected up to some other device that you're monitoring at the DART remote location, you can actually close a dry contact closure, and it would alarm back in through the host unit. You have a DC power supply module. This runs off of 24 or 48 volts and allows you to bring power into the system, and so that's what powers up the DART remote unit. Over on the right are the up to 8 DART cards, digital analog radio transceivers. And so these are the cards that would take the digitized RF, convert it into the IF frequency, which gets used on the cable TV system that drives the remote unit. So this is the expansion group, which consists of the DRU and the IFEU. You can include a power supply with that as well for applications where you don't have DC power available. So this unit will run off of AC power and provide the 24 or 48 volts to the DRU, and then the 54 volts that was required for the IF expansion unit. These are the remote access units that would be installed at the location that you're providing the wireless coverage. Every location would have a main unit that would be connected back to the expansion group, and in turn you can have up to 3 secondary units that would be cascaded off of the main unit. So you bring your single pair of cable TV 75 ohm cable into the main unit, and it provides the coverage for 2 bands. In this case I have an 850 and a 1900. And then this one has additional ports on it. It has 3 sets of ports that allow you to cascade to the secondary units. And so one pair would go to the first secondary unit, get 2 more bands. Second pair would go to another secondary unit to get 2 more bands. And then there's 2 more ports on here to get a 3rd set of secondary units. The main unit has an antenna port connected to it that would go off to your antenna. But each unit does have 2 bands, and so you can do all the North American bands at one location, up to 8 bands, to be able to provide wireless coverage. The units are without fans. They're just heat sinks, so they're very low maintenance. These units, once you install them, they're really just out there and they just do their work with really no maintenance required. And so they're very flexible in that respect. Also, you can have up to 128 of these units that are coming off of one host. And so the scalability of the system is tremendous. And so 128 units times 8 bands, you can see the capacity that you can put and the coverage that you can put into a Spectrum system. Okay, these are remote units that do the multiple bands at a given location. These units are capable of SISO and MIMO. MIMO, for example, the 700 unit I have here does MIMO. It has the 2 connections that are required and allows you to get the data rates that are going to be offered with the release of the 4G protocols. The remote access units at a given location will be connected to an antenna such as this one. And so this is the only visible part that the customers would see. All the other equipment would be in telecommunications closets or behind ceilings, and then you would bring out the wireless coverage through these antennas. We have a whole family of antennas depending on your requirements for how it were to look within your building or the location. Also, these units are multi-band, and so you don't need to have multiple antennas to do multiple bands. This one has 3 separate bands that come into it, and so you won't end up with an antenna farm to get the 8 bands of coverage at a given location. But very stealthy, fit in very well with the environment. Most people never even notice them. But these things really do take all the frequencies and the bands and shapes them and amplifies them to provide the coverage at that location. The InnoReach Spectrum distributed antenna system has a built-in element management system. And so in addition to the local LED alarming that you have within the hardware, built into the system is also an element management software package. And so you can get the local LED indications on the hardware, but you also get the reporting within the element management system. What I have here is a web browser that I brought up that I've logged into the system over the network, and now I can look at the system and determine the health of it. I can actually look at individual components to see what's going on there, or I can look at the overall health of the network. So this is all built into the product, allows this thing to really work right out of the box and be able to be accessed over a network and be monitored by your network operations center to ensure that you've got reliable coverage and service at all times. I'm going to highlight a couple of the key features of the element management system. So it's accessible through just a web browser. In this case, I'm using Internet Explorer. Firefox would work as well as others. But you just log into a network address, and you're able to log into the system to be able to manage it and check it for performance. Some of the areas on the GUI is you have a tree structure over on the left here that really shows you that you have a host unit connected up to various expansion groups, eventually going out to the remote access units. But you get a pictorial representation of the network of the system. And if you were to reconfigure the system, that would get represented here. If you were to add a fiber to another expansion group, it would show up in the tree. So very easy to add in capacity into the system, as well as adding in remote access units. If you were to add bands, they would show up here as well. And so you've always got this tree structure over there. You also have these indicators here that show you the alarm status within the system. You have major alarms, which are the red ones, and then minor alarms, which are yellow. So right now we have 2 major alarms and 24 minor alarms in the system. So you get an easy high-level summary of the alarm status. You can also bring up an individual status of the system. And so in this case, we see the 8 dartboards out here, and it's showing us the alarm status for various faults. And so you get a quick visualization of the alarm status of those dartboards. Additionally, you can look at the SFP or your optical status, and once again, the alarms that are applicable to the SFPs against the 8 SFPs that would be in that host unit. Some of the other features that we have is, everything is done through this taskbar and pull downs, and so very easy to navigate around and to find the various information that you're looking for as you manage the system. Another important feature of the product or the element management system is the online help. The documentation is built into the software, and so you can go right online and actually have access to the user manuals that are available with the product. You can get these in a paper copy, but these are the electronic version. And so if you have a question about what you're seeing in the system or how you need to do something, the information is readily available right at your fingertips to be able to do what you need to do. Another important feature of the GUI is that you're able to look at the alarms within the system. You can look at the current alarms that are currently active within the system. And so you get a display that shows you the severity of the alarm and the alarm name and the time and date that the alarm came in. And so very easy to kind of see what's going on if there are alarms in the system. And one other thing that I didn't point out earlier is that you can actually label the units. You can label your host unit and your expansion groups and your remote access units. And so you actually get unit names within the alarms that really help you identify where that unit is. In this case, it's a LabSys. This is one of the lab systems here, but I've named it LabSys, and so I know that that host is the lab system. And it also shows you, a little bit about the DART information, what bands are in use here, and so very easy to kind of understand what that alarm means to you. Additionally, there's also the history alarm file, so you can view the histories that maybe have come and gone within the system. And so another display that gives you all that information, the severity and the alarm name, and then the timestamp for when an alarm came in or cleared. Also in this file, you also get informational information that shows you if somebody were to log into the system or were to change a gain setting, all that would be captured in the alarm history file as well. Also in the alarm history and the alarm file is you have extended information. And so if you were to get this DART underdrive alarm, for example, which is a minor, you can go and you can click on the extended information, and it will come up and it will give you that alarm repeated, but it will also show you the unit that is in alarm. It will give you a description of the alarm as well as a remedy and the threshold. And so really, to get a one-line representation is a good starting point, but a lot of times you need to know what are the actions required in order to clear that alarm. And so that information is built right into the software and readily available to the user. So we talked a lot about the Spectrum's capabilities, the 8 bands, the 8 fibers, the ability to run 128 remote access units. So obviously a lot of scalability built into the product. But one of the key features of this type of architecture is, and it is a different architecture, it really is a distributed amplifier, is the ability to bring the coverage and the capacity to where the users are. And so, with 2G, 3G, and especially with 4G, where you have these high data rates, the user experience is getting more and more challenging. And so to have the transmitters right there where the needs are is the best way to build these high-quality networks. And so this way, the wireless service providers can provide the services that their customers are expecting. We do thank you for watching this presentation today, and we do appreciate your interest in the Spectrum product.